Welcome to Lesson 1-9, Introduction to Parent Functions. In this lesson, we're going to look at the general shapes of the parent functions that we tend to see, and then we're going to try and identify transformations that have happened to them. So let's take a look at the parent functions that are most common. Okay, the families that we're looking at are constant, linear, quadratic, cubic, and square root. This is what the parent functions actually look like. For constant, you would have f of x equals a number. The graph would be a horizontal line. It has the domain of all real numbers. Range is y equals whatever that number was that was up here. And it intersects the y-axis at 0, that number, from the constant function rule. Linear is f of x equals x. This is where you have x to the first power. It graphs as a diagonal line. It can be going upward, it can be going downward, but it would graph as a diagonal line. Domain is all real numbers, range is all real numbers, and it intersects the y-axis at 0, 0. The quadratic family is f of x equals x squared. This is where the x power is 2. It creates this parabola, this U shape here. Domain is all real numbers, y is greater than or equal to 0 for the range, and it intersects the y-axis at 0, 0. Cubic is f of x equals x cubed. This is where the x is to the third power. It creates this shape where it kind of comes up, it flattens out, and then it goes up sharply again. Domain is all real numbers, range is all real numbers, and then it intersects the y-axis at 0, 0. Finally, the square root function is f of x equals the square root of x. It has this shape where it comes up quickly, and then it's going to slowly flatten out, and eventually it'll look almost like a horizontal line. Domain is that x has to be greater than or equal to 0, because you're not allowed to do the square root of a negative number. The range is that y is greater than or equal to 0, because the square root of 0 is 0, and then the square root of all the numbers to the right of that are going to be positive values. And then it intersects the y-axis at 0, 0. So let's take a look at an example where we have to identify a parent function and then actually use a graph to say the type of transformation that happened. Okay, so it says to identify the parent function and use a graph to identify the transformation. In part A, we're given g of x equals x plus 5. Notice the power on the x is the first power. So the parent function is the linear parent function, f of x equals x. So I'm going to bring up my graphing calculator, and we're actually going to graph this function and its parent function. So let's see how that looks. So here's my graphing calculator. To graph on this, you would hit y equals. Then to get the parent function, which is f of x equals x, I would just type in x. Now this is the variable x that we use in our graphing menu, so x. And then to get the new one on there, I'm going to do x plus 5. Now, I'd like to use Zoom Standard, which is number 6. And that one tends to show me everything that I need to know. Please note that the blue line is the original parent function and the red line is the new one. So this one has been translated up 1, 2, 3, 4, 5. So this is, the parent function is the linear one, and the transformation is that it has been translated up 5. Let's look at B now. It gives g of x equals x minus 3 squared. Notice this x is being squared. Even though it's outside the parentheses, the x is in the parentheses, meaning the square is occurring to it. So that means that our parent function is the x squared parent function. So x squared is here. And now I need to type this function exactly as it appears. So parentheses x minus 3 parentheses squared. And now let's look at the graph. So the blue one is the parent function. The red one is the new function. Notice it has moved to the right 1, 2, 3 points. So this is a horizontal translation to the right by 3. So quadratic parent function, horizontal translation to the right by 3. In part C, they give us this. Notice it says x cubed. So that means my parent function is the cubic power function. So I have x to the third power here. Now I'm going to type in this function. I have to clear out what's there, and then I type x to the third power and then plus 2. And make sure you get out of the exponent before you put plus 2 there. Sometimes it doesn't go out automatically, and then you'll get something that doesn't look right. So here, the blue is our parent function, and then the red is our new function. So notice it's almost exactly the same, except now it's gone up 2 spaces. So cubic parent function, and it's a vertical translation up by 2. Now finally, in part D, they give us g of x equals negative x to the second. So notice I have an x to the second. That's quadratic, so I'm going to put in the quadratic parent function. And again, I'm going to type this function exactly as it appears. So parentheses, negative x, parentheses, squared. And now I'll go to my graph. Okay, so notice the red function's right on top of the blue function. So they have done something with this. We just don't know what it is. But it is a type of reflection. So if you watched my lesson 1.8 video, you will notice that multiplying by a negative is a reflection. And the only reflection that would get us exactly to this point is if it reflected across the y-axis, because any point that's on the right side would reflect right here to the left side. Any point on the left side would reflect right here to the right side. So this is a reflection across the y-axis. Okay, so let's take a look at one where we have to use a table of values to graph and then identify the parent function from that. Okay, it says to graph the data from the table, describe the parent function and the transformation that best approximates the data set. So all I did is I took my table and I graphed the points, these red dots, then I connected them with this line here. So notice the shape, it's a U shape. That U shape is the quadratic shape. So the parent function is the quadratic parent function. Now the normal points for a quadratic parent function, and I just picked a few of them. I did 0, 0, 2, 4, and 4, 16. All it does is it takes your x value and it squares it. So 2 squared is 4, 4 squared is 16. If I had 3 here, 3 squared is 9. You get the point 39. And now what I'm going to do is compare these points with the points I had up here. 0, 0 stayed the same, but 2, 4 turned into 2, 2. They either subtracted 2 or divided it in half. Notice what happened at 4. It's supposed to be 4, 16. Now it's 4, 8. 8 is half of 16. So they have multiplied the y values by 1/2. This is a vertical compression by 1/2. Okay, and if you can't tell that, I would definitely recommend watching my lesson 1.8 video where we go over those descriptions. We have one more example for this. In this one, they have still given us a table of values that we have to graph, but we also have to describe the parent function and estimate a value from this. It says an oceanographer wants to determine a model that can be used to estimate wind speed based upon wave height. Graph the relationship from wave height to wind speed and identify which parent function best describes it. Then use the graph to estimate when the wind speed is 10 knots. So all I did is I used the wave height as x and the wind speed as y. Because it says the relationship from wave height to wind speed. That means I'm given wave height and I'm getting wind speed, meaning this is my independent variable, this is my dependent variable, x, y. So I graphed my xy pairs with these red dots and I connected them with this tan line. Okay, this shape, notice it goes up quickly and it slowly flattens out. That is the square root function shape. So this is a square root function. And then to estimate the when the wind speed is 10, I find 10 on my y-axis. I go over and I find the x value that corresponds, and that's about 2.5. Okay, so that is my estimate. So the wind speed is 2.5, the wave height is 2.5 when the wind speed is 10. So that's it for this video. Let me know if you have any questions.